Okay, for today's class, I want us to look at halogenation of alkanes. In simple terms, halogenation of alkanes is just an alkane reacting with a halogen to give us a haloalkane and hydrogen halide, right? What I'm saying is that halogenation of alkanes involves substituting a hydrogen atom in an alkane with a halogen atom through free radical substitution mechanism. Remember that alkanes are what? Are saturated hydrocarbons. That is to say that alkanes do not undergo addition reactions, but they undergo substitution reactions. That is to say that for us to be able to add an extra atom to our alkane, we need to remove one of the atoms from the alkane first, right? Now, for us to achieve halogenation of alkanes, there has to happen what we call the free radical substitution mechanism. And this mechanism comprises of three steps. That is the chain initiation, chain propagation, and chain termination. For this class, I want us to consider the reaction of ethane with chlorine. So we say that the first step is chain initiation. So what happens during chain initiation is that the chlorine molecule breaks into two chlorine radicals in the presence of UV light or heat. Now, I want you to take note of those arrows, right? Those arrows are what? Are half-headed, right? And for this mechanism, we are only going to use half-headed arrows. And the chemistry tells us that half-headed arrows, they show movement of only one electron. And as for full-headed arrows, they show movement of an electron pair. That is two electrons, right? One may ask, why are we breaking the chlorine molecule instead of the alkane, right? The chemistry tells us that the chlorine to chlorine bond is weaker than either the carbon to hydrogen or the carbon to carbon based on bond energies, and is therefore the easiest to break. And also, we are saying that the source of energy for this step is light or heat, right? If light or heat is the energy source, the chlorine molecule absorbs the energy, but alkanes do not. Hence why it's easier to break the chlorine to chlorine bond, right? Now, moving on to the second step, that is chain propagation. So during chain propagation, what happens is that the first step for chain propagation, the chlorine radical abstracts or removes a hydrogen atom from ethane to produce the ethyl radical. We are saying that for the first step of chain propagation, the chlorine radical from the chain initiation step is going to abstract or remove a hydrogen atom from ethane to produce ethyl radical. Now, as for the second step of chain propagation, what happens is that the ethyl radical, it abstracts a chlorine atom from a chlorine molecule and chloroethane is formed. And in the process, a chlorine radical is regenerated. Now, moving on to the last step, which is chain termination. During chain termination, that is the end of our reaction, right? So what happens is that the free radicals, they combine to form products, thereby terminating the chain, right? We are going to have the chlorine radical reacting with another chlorine radical to form chlorine molecule, right? And we are going to have our ethyl radical reacting with another ethyl radical to form butane, right? And we are going to have our ethyl radical reacting with chlorine radical to form chloroethane. Ladies and gentlemen, that is the end of our class. Thank you.